Unit overview. The unit consists of 5 major sections: the compressor section, condenser section, evaporator section, control box section, and the electronic part blow section. The compressor section. The compressor section includes compressor, discharge valve, suction valve, high pressure switch safety, pressure regulator valve, stepper suction modulation valve fitted on the newer units, which replaces the suction modulation valve and the suction solenoid valve for the older ones, quench valve, and supply air sensors. Microlink units are fitted with 2 supply air sensors. One sensor is needed for recording data and the other one for controlling cargo temperature. Power cable, unit identification plate, interrogator connector needed to retrieve data, receiver tank, king valve, filter dryer, condenser section. The condenser section includes air-cooled condenser coil, condenser fan grill, condenser fan, condenser motor. The condenser fan causes air to be drawn from the bottom of the condenser coil and to be discharged through the condenser fan grill. Evaporator section. The evaporator section includes access panels motors, heaters and TXV access panel, fresh air vents. The purpose of the fresh air vent is to provide ventilation for commodities that require fresh air circulation. The vent must be closed when transporting frozen cargoes. To adjust the percentage of airflow, loosen the nut and rotate the disc until the desired percentage of airflow meets the arrow. Refasten the nut. Evaporator coil. 2 evaporator fans and 2 evaporator motors. TXV valve and bulb. Heaters. Defrost sensor. Return air sensors. Microlink units are fitted with 2 return air sensors. One sensor is needed for recording data and the other one to control cargo temperature. On some units, the 2 return air sensors are replaced with one sensor called a combi sensor. Humidity sensor. Connections for the USDA sensors inside unit. The evaporator fan motors ensure air circulation all over the cargo and also through the evaporator coil fins. Heat from the cargo is transferred to the refrigerant inside the evaporator coil. Control box section. The control box section includes contactors, transformer, main circuit breaker safety, RMM remote monitoring module, controller and data logger for ML2 models, display, keypad, on-off switch. Electronic part blow section. The container refrigeration unit is designed to be installed in front of the container and to maintain the cargo at the desired temperature by allowing air to circulate throughout the box. Identification plate. The identification plate is a metal or plastic plate fastened onto the unit's frame located on the left side of the compressor, on which all the information related to the type of the refrigeration unit is mentioned. Model number indicates the engine type and shows which configuration and software has to be loaded into the controller. Parts ID number. Serial number, to be stated when replacing parts on Reefer units still under carrier warranty. Date of manufacture. Type of refrigerant and quantity. The date since the unit has been in service. Warranty period. Components under warranty. Refrigeration cycle. The refrigeration system absorbs the heat of the cargo at the evaporator and rejects heat at the condenser to the ambient air. Starting at the compressor discharge service valve, the high-pressure, high-temperature superheated vapor passes through the discharge line to the discharge pressure regulator. The discharge pressure regulator ensures that the discharge pressure never drops below 5 bar. This is necessary to avoid the suction pressure reaching the vacuum that could result in oil foaming and loss of compressor lubrication. Superheated vapor continues through the discharge line up to the air-cooled condenser. Ambient air is forced from the condenser motor through the fins of the coil to extract heat from the refrigerant, which is then transferred to the ambient air. The refrigerant is cooled to its boiling temperature and it will condense into a liquid. The refrigerant from the condenser passes through the liquid line to the receiver, which has 2 sight glasses to determine refrigerant charge level. The receiver holds the excess refrigerant. From the receiver, the refrigerant passes through the liquid line to the King valve. This valve can be used for adding or removing refrigerant. From the King valve, the high pressure and high temperature liquid reach the filter dryer, which will filter out any solid parts and moisture to prevent system damage. Between the filter dryer and the moisture liquid indicator there is a small valve, the quench valve. The quench valve is a small TXV valve which monitors the suction line temperature. If the suction line temperature should become too warm, the quench valve will open and it will allow a small amount of liquid into the suction line to cool off the compressor windings. This is necessary to prevent overheating of the compressor's windings. The high pressure and high temperature refrigerant will reach the heat exchanger. In the heat exchanger, the high pressure and high temperature refrigerant transfer heat to the low pressure and low temperature vapor, returning to the compressor. This will improve the efficiency of the system. The refrigerant arrives at the thermostatic expansion valve TXV, which measures the amount of refrigerant entering the evaporator coil. As the refrigerant passes through the TXV valve, there is a pressure drop from the high side to the low side of the system. The low pressure and low temperature saturated mixture from the TXV valve enters the evaporator coil. The air circulating over the cargo by the fan motors is also circulating through the evaporator coil fins. Heat from the cargo is transferred to the refrigerant inside the evaporator coil. Heat is absorbed, causing the refrigerant to boil into a vapor. The low pressure and the low temperature superheated vapor in the suction line passes through the heat exchanger and flows to the suction modulation valve. This valve is a valve with an infinity opening to ensure the system reaches the desired box temperature. For frozen cargo, when more capacity is required, the suction solenoid valve will open as well. On the newer type, the suction modulation valve and the suction solenoid valve are replaced by a single valve, called the stepper suction solenoid modulation valve. The refrigerant vapor completes the cycle and it will return to the compressor suction service valve. Controllers and spare controllers supplied on board. The controller is a microprocessor designed to control, record the temperature. It works with 18-volt AC power provided from the transformer located in the control box. The controller first receives inputs, voltages, from the sensors and switches, and then generates outputs to the relays based on the inputs. The input information is processed by the controller operational software. The operational software is the set of instructions that the controller follows once powered up, and it determines what outputs are generated for a particular set of inputs. We have three types of Reefer units fitted with the controller: Microlink 2, Microlink 2i, and Microlink 3. Microlink 2 units are the 69N240-489 and 69N240-501 models. These models have two components mounted in the electrical box: the controller and the data recorder. The data recorder is an option on these models, and it is not always fitted. Only the controller is needed for the working of the Reefer. The data recorder is only fitted for recording information, such as recorder sensor temperatures, real-time clock values, etc. And it has nothing to do with the good or bad working of the Reefer, so please just ignore it. The software program version for the Microlink 2 is number 1207. Microlink 2i units are the 69N240-511 and the 69N240-521 models. These models have only one component, which includes both the controller and the data recorder. The Microlink 2i controller can be mounted onto the Microlink 2 units with the correct operational software. However, the Microlink 2 controller cannot be mounted onto the Microlink 2i units. The software program version for the Microlink 2i is number 5132. Microlink 3 units are the 69N240-541 model. These models have also only one component, which includes the controller and the data recorder. The Microlink 3 controller is compatible to the Microlink 2i with the same operational software number 5132, but it cannot be mounted onto the Microlink 2 units. However, the Microlink 2i controller cannot be mounted onto the Microlink 3 units either. The software program version for the Microlink 3 is number 5132. The Microlink 3 controller has the step driver motor installed inside, which regulates the opening of the stepper valve, whereas the Microlink 2i unit's driver motor is installed next to the valve into the compressor section. Very important, the model number of the unit is printed on the identification plate. Spare controllers present on board. Each vessel is supplied with two different types of controllers. The Microlink 2i controller, compatible on units Microlink 2 and Microlink 2i. The Microlink 3 controller, compatible on units Microlink 2i and Microlink 3. By installing the 1207 operation software in the Microlink 2i controller, it's ready to be used on a Microlink 2 unit. By installing the 5132 operation software in the Microlink 2i controller, it's ready to be used on a Microlink 2i unit. By installing the 5132 operation software in the Microlink 3 controller, it is ready to be used on a Microlink 2i and Microlink 3 unit. Software and configuration are loaded into the controller by using the software configuration cards. The operational software contains the complete unit operating instruction set. It tells the controller hardware what to do. Very important. After loading the operational software, always load the controller with the unit model number by using the configuration card. The configuration file contains the complete list of the available unit model numbers, including the unit options. Controller functions codes, alarms, auto PTI, keypad and display. Keypad. The keypad consists of 11 buttons which allow the user to get information from the controller. The code select key gives access to the function codes. The pre-trip key displays the pre-trip selection menu. The alarm list key displays the alarm list and clears the alarm queue. The manual defrost interval key displays the selected defrost mode. Pressing this key for 5 seconds will initiate a defrost. The Enter key confirms a selection to the controller. The arrow up-down key changes and scrolls a selection. The Return Supply key displays the non-controlling probe temperature. The Celsius degree and Fahrenheit degree selects both scales. The Battery Power key allows set point and code selection when the unit is not connected to a power supply. The Alt Mode key allows the user to interrogate the data recorder. Display. The display has 2 windows, the left one showing the set point and the right one showing the supply and return air temperature readings. Cool. White LED indicates that the compressor is energized. Heat. Orange LED energized during heat or defrost mode. Defrost. Orange LED indicates unit is in defrost mode. In range. Green LED indicates temperature of set point in range. Alarm. Red LED indicates an active or inactive alarm.